We are going to see about cryptography. Cryptography, it is a word that is used in network security system. If you know about some network security methods, cryptography is one of the method used for secure communication. I am G.Sivakumar, Assistant Professor, Computer Science Department from PSN College of Engineering and Technology. Okay, let us start our session. First, introduction about cryptography. So, cryptography, the word crypto means writing some words or some text in a secret manner. So, it is also known as science of writing in a secret manner. Here we are having so many languages, so we need communicate that language text. So in the basis, the text are nothing but a code. So cryptography is a science of writing in a secret code, and it is one of an ancient art of writing. Because it was during when the first cryptography was introduced during war times. So in ancient period, some battles were done. That time we need a communication for a secure manner to convey from one side to another side. So during battlefield, that communication is secure. So the cryptography is also known as a ancient art of writing, and it is necessary while communicating over untrusted medium like internet. Next, during ancient period, some puzzles and cryptograms in archaeology are used. So here are some ancient stone based some crypto writing. In previous ancient time, whenever there is the language is not developed, at that time some art of writing is done in the cryptography. So this is some example ancient period cryptograms and puzzles in archaeology. Next, definition. So cryptography, already I told, cryptography is science of art. So it is having two parts. One side is encryption and another side is decryption. Then crypt analysis. Crypt analysis means the breaking of encryption. Whenever the sender send the data from their side, sender side, whenever it goes to receiver side, some text are encrypted. So the cryptography means the art of encryption, and crypt analysis means breaking of encryption. So the new word formed from cryptography and crypt analysis is called cryptology. So the cryptology is nothing but the combination of cryptography plus crypt analysis. Some security requirements, and today's world we need a internet for our daily purpose. Nowadays, lot of people from all over the world using internet. So some securities are present in the internet. The first one is authentication. So authentication is nothing but the one's identity. Next, privacy and confidentiality. Confidentiality means it is secure one. to ensure that no one can read the entire message or entire data. Whatever the data that can be communicated, that data must be ensured. No one hack or no one need to access that data. It's going to the correct data going to receiver. Just integrity. The message received by receiver is not altered. If you send some message from sender side, that the message, the overall message, what are the content present in the message, that actually delivered to the receiver. This is integrity. No one can alter or no one can change during the transmission time. Then non-repetition. To prove that sender has really sent the message, the receiver knows which sender sent the message to me. So this is non-repetition. So these are some security requirements for cryptography: authentication, privacy, confidentiality, integrity, and non-reputation. Next, working of cryptography. How the cryptography work? So it's a simple communication that sender send data to receiver. Then what type of data and how the data can be encrypted and decrypted both side. If the encryption takes place, it is in sender side. If the decryption takes place, it is in receiver side. Okay. The first point, the message to be sent is known as plain text. That is the original message. If you send the content of data, that original message, in cryptography it is called as plain text. The original data that can be sent by sender is plain text. Then the plain text is converted, the original message, that is the plain text, is then converted into some unreadable form by some algorithms or some key. So cryptography concept is the original message is encrypted. Encrypted means if you send message, how are you, the original message is not sent to receiver. The data can be encrypted, means some alternate will be, the original message cannot be displayed. This and so some algorithms are used in the cryptography. For encryption and decryption, some algorithms are used and some key values are used to encrypt and decrypt. Okay, these algorithms are known as ciphers. The unreadable form is known as ciphertext. The data, the text that is to be unreadable, that unreadable form is known as ciphertext. So the cryptography consists two type of testing. One is plain text and another one is ciphertext. Plain text is in sender side and ciphertext is in receiver side. Plain text is encrypted and ciphertext is decrypted. This is the working of cryptography. Next, there were, I already told that encryption and decryption. So in technical world, in a data communication networking, the cryptography used plain text is nothing but the process of conversion of plain text to ciphertext. That is, the original message can be encoded or the original message can be altered, is known as encryption. So next, decryption. Once encryption done in sender side, automatically the decryption done by receiver side. The process of conversion of ciphertext to plain text, the vice versa, opposite range. In sender side, plain text to ciphertext, and opposite side, receiver side, that ciphertext converted into plain text. Why ciphertext is converted into plain text? Because the original message can be reached to the receiver. So whenever encryption takes place in the sender, automatically decryption take place in the receiver. So in Asian period, this encryption and decryptions are mainly used in military and some government secret communication. In old Asian days, some country military can or send the data using secure. So this encryption and decryption methods are mostly used in military communications and some government secret communication. Some governments are not ready to share their data and their country documents to another country. So this type of applications and this type of communications are used by encryption and decryption. And encryption is used in many kinds of civilian systems like internet, e-commerce, mobile telephone. Next, cyber test and plain test. Cyber test contains all the information of plain text message. So if you send the message from plain text, what are the data that we sent, that whole information can contain in the cyber text, but not in a format readable by human or computer without a proper mechanism. So whenever the encryption takes place, it cannot be hacked because the original code cannot be sent. Some encrypted code only sent during communication. So when the encrypted message reach to the receiver side, it must be decrypted. So during decryption, some algorithms are used. So without a proper algorithm or without a proper mechanism, no one can't decrypt the message, and it is not a human understandable form. Cyber and its types. So the plain text and cyber text we seen. Now the cipher and its types. So cipher is an algorithm for performing encryption and decryption. Okay, cipher is a word that indicates the algorithm for performing encryption and decryption, and that is a series of well-defined steps. So what are the steps that we follow for encryption and decryption? It must be standardized one. So there are two types of cipher. One is historical cipher and another one is modern cipher. One is historical cipher and another one is modern cipher. Historical cipher. So historical cipher means it is also known as classical cipher. And substitution cipher. Historical cipher is another name of substitution cipher. In this, one alphabet is substituted for other. There are 26 alphabet in the English alphabetical order. If we send the message as a text in the alphabetical text, that original alphabetical text can be altered some other alphabet. Example, here good dog. The sender send the message to the receiver as a good dog. The original good dog message must encrypted during transmission. So that good dog message can be encrypted as PLLXXLP. Here G is replaced P, O is replaced by L, and another O is replaced by L, D is replaced by X, D is replaced by X, O is replaced by L, and G is replaced by P. So here P is substituted for G, L is substituted for O, and X is substituted for D. So this substitution only takes place during encryption. That original message good dog is not sent during communication. So this is historical cipher. Simple substitution cipher. Here there are so many alphabets that are randomly placed in the cipher text. In the above, there is a box. Decipher the following text, which is a quotation from the famous scientist. Clue: Z stands for E. So here the background yellow color box, there are so many alphabet text are available. Each text where the Z present, that Z must be altered or changed or substituted by the letter E. So CEBAYUC YX SENM PDZ. So here the PDZ, the Z can be altered by E. So the next letter, the Z present in which letter, that Z must be encrypted by E. Simply knows the letter can be altered, Z to E. So then we solve the time step. Okay. Next, transposition cipher. Here the letters are transposed. In previous type, historical cipher or substitution cipher, the word replaced by another alphabet. In previous example, we saw the Z can be replaced by E, another alphabet. But here transposition cipher means the letters are transposed. The original message, for example, take a previous example, good dog can be encrypted as DGO and GDO. The letters are transposed their original message. So sometimes this is acceptable encrypted message that we transmit from sender to receiver. So here the early version of cipher is Caesar cipher. Caesar cipher is named after a famous scientist, Julius Caesar, who used it first. Here Caesar cipher. So you substitute one piece of information to another. Here it substitute one piece of information to another. Some algorithms are set. To change the letters, to change the alphabet from replaced by another or replaced by some technical letters, something. So here the key is the number of characters to offset it. Example, ABCD alphabet A to Z, sliding every character by 3. So here the example, there are 26 alphabet letter continually, sliding every character by 3 means first ABC replaced by the last one ABC. So continue, then next 333 letter the encryption can be made. It is Caesar's cipher. Next, modern cipher. So nowadays, in previous slides are shown, the encryptions are took place during the old Asian period, that transposition, that substitution fiber, historical fiber. Now in our latest technology so well developed, nowadays modern cipers are used. So the modern cipher classification on the type of key used, two keys. One is symmetric key algorithm and another one is asymmetric key algorithm. So symmetric and asymmetric. So classification on the basis of type of input. The above classification is based on key, symmetric key and asymmetric key. Then the next classification is based on the type of input we given to the sender during transmission whenever it reaches the receiver. That is block cipher and string cipher. So block cipher is the encrypt block of data, and the string cipher is encrypt continuous stream of data. So if we send the message in block cipher, the whole data can be encrypted. So the set of data is called a block of data. that block of data can be encrypted in the block cipher. But in the stream cipher, the encryption continuous stream of data. Continuous stream of data means if the message contains 4 blocks of data, then first block can be encrypted. Once first block of data encryption finished, the next set of blocks of data can be encrypted. So this process can be continued in the stream cipher. Next, Pigpen cipher. So Pigpen cipher is nothing but some shapes. The shapes you can see, that is a L, reverse of L, or greater than, or less than, or up or down, or sometimes there is a dot present, or there is a point or dot present inside the square or rectangle, something like that. So the Pigpen cipher consists of so many shapes available. So here the encoded message, the total 26 alphabets are termed as the A, B, C, D, E, F, G, H, I. It is in the matrix formats, 3 by 3 row and column. And next, JKL, MNO, PQR. JKL, MNO, PQR. It is also a matrix 3 by 3, but there is a dot present inside the box. And next, there is a diagonal one, cross diagonal one. Here the 4 letters are present. Next 4 letters are S, T, U, V, and the last 4 letters W, X, Y, Z. So here a dot is present inside the cross diagonal. So if we send the data, for example, how are you, HOW, AREYOU. So here the H is present in the square box, and R, it is present in the square box. Top left corner there is a dot, that is a shape denoted for R. And how, HOW, O, that is, and the dot present left side. Then W means cross diagonal upper side. So this type of words are altered by using this special dotted and undotted shapes. So this is Pigpen cipher. So this is a substitution cipher with all the some weaknesses of such cipher. So here T, H, I, S. So here are some message, the original message can be encrypted using that particular word corresponding to the particular shape. Next, more sophisticated substitution cipher. This is a word one that is replaced, the letter A has been replaced by C, D, X or E in different position. So it is one type of rotating wheels that consist of 25 continually arranging the letters. So the letter A can be replaced by some alphabet C, D, X or E, and the letter T can be replaced by some letters M, W or X in the different position. So when we rotating the wheel, the original message can be encrypted using the replaced by the another position of letter. So the red color indicating that letters are message, and the blue color indicating the letters are cipher. So encryption. So this is the rotating wheel. Next, key. Next one is key. So key is nothing but a piece of information, or it is also say as a parameter or some variable or some parameter, some variable. It has a set of rules that determines the functional output of the cryptographic algorithm. So the word key is almost used in the algorithms, cryptography algorithms. So without the key algorithm would have no meaning. So without key there is no algorithm for cryptography. Types of cryptography algorithms. What are the types that are present in the cryptography algorithms are secret key cryptography. One of the type is secret key cryptography. That already I know the types that is based on the key, symmetric key and asymmetric key. So here the symmetric key algorithm is also known as the secret key cryptography. Okay, the key is nothing but there are two keys present in the cryptography. The one is private key and another one is public key. The one is private key and another one is public key. Here in the secret key cryptography, that is also known as the symmetric key cryptography, private key algorithms are used. So it uses single key for encryption and decryption. So if the algorithm used by the private key, the both sender and receiver has a private key, single key. Next, public key cryptography. So private key cryptography is symmetric key cryptography and public key cryptography is a asymptotic key algorithm. Here two keys are used. One key is used for encryption and another one is used for decryption. Okay, in the symmetric key cryptography there is only one key, that is private key. That private key is used to both sender and receiver. But in the public key cryptography, that is asymmetric key cryptography, it is also known as asymptotic key algorithm, and it uses two keys, one for encryption and another one for decryption. Next, hash function. So this is also one of the algorithm that is used in the cryptography, is called hash function. So here there is no private keys or public key. It has some mathematical functions to encrypt the information. Next, symmetric key cryptography. So symmetric key cryptography I already told. The symmetric key cryptography or private key cryptography. Here the single key used for encryption as well as for decryption. Here the key must be known to both the sender and receiver. If you send the data using this key, the single key, that single key can be known for both sender and receiver. For example, if you send the data using with key A, the key A is also present in the receiver side. So both sender and receiver must know the key value. Next, some secret key cryptography algorithm. So some symmetric key cryptography algorithms are data encryption standard. Data encryption standard. So the first, the data encryption standard, shortly abbreviated as DES. It was designed by IBM in 1970. It was designed by IBM in 1970. IBM means nothing but International Business Machine. So it is a block cipher employing 56-bit key on a 64-bit block. So here the 64-bit block means the 64-bit block of data can be present in the algorithm. Using that 64-bit block of data, the available key pair is 56-bit keys are available. So it is designed to yield fast hardware implementation and slow software implementation. So the data encryption standard algorithms are very much fast in hardware implementation applications and is much slower in software implementation applications. Then advanced encryption standard. So the previous slide we saw the data encryption standard, but here it is a advanced encryption standard. Okay, it was designed in 1997. So the past 20 years back it was invented and designed for US government, United States government. This algorithm can use variable block length and key length. In the previous data encryption standard, there is a block of data and a key value, but both are the fixed one, fixed 56 and something. Here this advanced encryption standard designed by US government as a variable block length and key length, variable block length and key length. Here the key length and block length can be of 128, 192 or 256. 128 or 192 or 256. Next one, International Data Encryption Algorithm, IDEA, shortly known as IDEA, International Data Encryption Algorithm. So it was developed in 1992. It is a 64-bit block cipher and a key size is 129-bit. So 64-bit block of data can be available in the International Data Encryption Algorithm, and the key size has a 129-bit of data. So some other algorithms that are used in the International Data Encryption algorithms are cast 128/256 and reversed cipher, blowfish, twofish, Camilla, Misty 1, Kazumi, Seed, Skipjack. These are some algorithms that are related to the International Data Encryption algorithm. Next, public key cryptography. So previously I told that asymmetric key cryptography are known as public key cryptography using two keys. One is public and one is private. There are two keys present in the public key cryptography, asymmetric key. The one key is called public key and another one is called private key. Okay, private key is kept secret. So the authorized person only use the private key. So it is secret, always kept in secret. And public key may be widely distributed. So public means it is a general. So anyone can easily access the public key. Next, the message encrypted with a public key can be decrypted only with its corresponding private key. So the message will be sent from the center side, and that time the encrypted takes place with a public key. The corresponding decryption, what are the message that we encrypted using public key, that can be decrypted only by its corresponding private key. So for asymmetric key cryptography, both public key and private keys are used during data communication for encryption and decryption. Next, two main branches, public key encryption and digital signatures. Public key encryption and digital signatures. So okay, next, anyone can encrypt using the public key, but only the holder of the private key can decrypt. So already we know the public keys are not secure. It is widely distributed and widely used by another person easily. So it is not a secure one. So anyone can encrypt using the public key, but the holder of the private key can decrypt. So corresponding public key, the corresponding whatever the person who has a corresponding public key, private key, the private key can decrypt. So secrecy depends on the secrecy of the private key. Next, algorithms used are. So some algorithms used are RSA algorithm. It is one most popular algorithm that is used in the cryptography. It was developed by Ronald Rivest, Adi Samir and Leonard Adilman. The first letter from the Rivest, Samir and Adilman, the RSA algorithm formed. So it is used for some key exchange digital sign or encrypting small blocks of data. So RSA algorithm is one of the encryption algorithm used in the cryptography. So it takes place during transmission that a key can be exchanged, or some it take part digital signature, or some encrypting some small amount of data, so small blocks of data. Here the key pair is the product of two prime numbers. The primes can be 100 or more digits in length each. The block of data, that the entire block of data is the length of data can be 100 or more digit. So it is safe and it is difficult to factor large prime numbers. So using RSA algorithm, the encryption and decryption takes place during communication from sender to receiver side. It is a safest one for cryptography. Some other algorithms are Diffie-Hellman algorithm, and digital signature algorithm, and L-Gamal algorithm, and elliptic cryptography algorithm. These are some algorithms used in the cryptography. Next, digital signature. So digital signature, the word says that you all know signature by the person writes the name in some different format. So the digital signature is one of the type of asymmetric cryptography, that is a private key cryptography, public key cryptography. There are two algorithms present in the digital signature. One for signing, which use user's private key, and one for verifying, which use user's public key. So the signature must have two algorithms, one for signing by using private key, and another one for verifying using public key. So here the output of signature, the whole processing during transmission, whenever we use the digital signature using private key and public key, one for signing and verifying, the whole process during communication or during transmission, then the final output of the signature process is called digital signature. Here anyone can check the signature using the public key, but using private key only the validating person or some authorized person, or it has some validity, depends on private key security. So here in digital signature, each individual generates. So each person or each user can individually generate his own key pair. The user can make his own key pair, private key and public key. So private key only to the owner and public key known to everyone. So here the private key used for making digital signature and the public key used for verifying the digital signature. So the private key takes place in the sender side and the public key takes place in the receiver side to verify the correct message or sent from sender to receiver. Next, this is some difference between paper signature versus digital signature. So the parameter considers are authenticity, integrity and non-repetition. So here the authenticity during paper may be forged. So here the forged takes place easily, but in electronic cannot be copied. So in paper the authenticity can be easily, so if you put a signature by your own handwriting, it can be easily assessed or easily known by some other person. That hacking person can be easily written your signature in the paper. So it is not a secure one, so it is a forgery. Then the electronic cannot be copied. So the electronic signature cannot be copied by some other person. So authenticity is very important whenever we compare the paper signature versus digital signature. And next one is integrity. So integrity is nothing but the signature independent of the document. the signature independent of the document. If the user put signature in the document, that is independent, but in the digital signature, electronic signature depends on the content of the document. The electronic digital signature, it is related to the content of the document. So next one, non-repetition. Non-repetition means in paper side, handwriting expert needed. So the expert handwriting persons are needed, error prone. Here any computer user are error free. So these are some limited differentiation or comparison between paper signature versus digital signature. Then what are the steps followed in creating digital signature? The first one is message digest. So message digest is the block of data, the block of message can be compressed, or it may be say as digest computed by applying some hash functions on the message. So hash functions are some mathematical calculations that we are computing whenever we apply the message digest on the message, and then the message digest is encrypted using private key of sender to form a digital signature. The next one, digital signature is encrypted using private key plus message digest, and message digest is message digest algorithm. The message digest can be made during some message digest algorithm, and digital signature is made in encryption using private key plus message digest. Then the digital signature is then transmitted within the message. So at last, message plus digital signature is transmitted. Next, in previous slide, the process takes place in the sender side, and here the process takes place in the receiver side, that is decryption. So here the receiver decrypt the digital signature using public key of sender, not a public key of receiver. Okay, the sender must use the private key with the help of message digest plus corresponding digital signature, and other side, the receiver side, decrypt the digital signature using the public key of sender. So this assures authenticity. As the only sender has his private key, so only sender can encrypt using his private key, which can thus be decrypted by sender's public key. So the receiver now has the message digest. So the message digest can takes place on both sender side as well as receiver side. Here the receiver can compute the message digest from the message. The actual message is sent with the digital signature. So the message digest already we know it takes place during both sides, sender and receiver. At the receiver side, the actual message is sent with the digital signature, and the message digest computed by receiver and the message digest need to be same for ensuring integrity. So here in the digital signature, the message digest takes place, and the sender side private key and the receiver side public key. During at the receiver side, the message when received, it must be decrypted using the public key of sender. So in digital signature, it need to be same for ensuring integrity. Next, what are the benefits? When we using in the digital signatures or authentication? The first, the very important and foremost benefit is authentication. The secret key is bound to a specific user and a signed source that message was sent by the user. And integrity, if the message is digitally signed, then any change will invalidate the signature. So if you put the signature as a digital, it cannot be moderated or it cannot be altered by another person. So if any another person hacked, the signature must be invalid. The digital signature must be invalid. Then drawbacks. Drawbacks of digital signature is no certainty about the date and the time at which the document was signed. So whenever we put a sign in a digital format, that particular date and time we cannot be known at which document was signed. So this is this is one of the drawback that we use in whenever we use a digital signature. Next, digital certificate. So digital certificate is some related process and related similar to digital signature. It is issued by the trusted third party. It is used by the trusted third party. That trusted third party must known by the sender and receiver, which proves sender's identity to the receiver and the receiver's identity to the sender. So digital certificate is issued by the trusted third party. Digital certificate is a certificate issued by who issued the digital certificate means certificate authority to verify the identity of the certificate holder. To verify the identity of the certificate holder. So digital certificate is used to attach public key with a particular individual or an entity. Then digital certificate contains what are the parts or what are the informations or what are the details that are present in the digital certificates or name of certificate holder. So the name must be important for certificate holder and the serial number which is used to unique identify a certificate. Nowadays we see a lot of certificates that are available by so many companies or so many government sectors. Some educational government sectors issue the certificates to students. It has a serial number. So the serial number are not same for all student. It is a unique serial number for each and every one of the student. So next, expired date. The expired date of digital certificate and the copy of certificate holders public key used for decrypting message and digital signature. So digital signature of the certificate issuing authority. So these are the details that are the information contained in the digital certificate. Then advantages. What are the advantages of digital certificate is the first one is network security. The next one is verification and the last one is buyer success. So whenever the receiver received the message, it is a successful one in the digital certificate and it is also a verification and it has a network security. Next, disadvantage of digital certificate, some phishing attacks. Some phishing attacks means the original data can be modified. Original data can be modified during transmission and the weak encryption. Sometimes the data cannot be strongly encrypted. 100% encryption not takes place during in the digital certificate and misconfiguration. So misconfiguration is one of the important disadvantage whenever we configure the communication of data between the sender and receiver. Next, hash function. Already we know the hash function. It is a one-way encryption. It is a one-way encryption technique and use no key. So why we need not key for hash function is hash functions are some mathematical calculations for both the sender and receiver side for encryption and decryption. And here in the hash function, it is a fixed length hash value is computed and hash algorithms. Hash algorithms are used to provide a digital fingerprint of file's content, which ensures that a file has not been altered by an intruder or by a virus. So here in hash function, it is a one-way encryption technique and it is a fixed length hash value and some hash algorithms are used to provide a digital fingerprint. So here hash functions are employed by many operating systems to encrypt passwords. So this is a cryptographic hash function. Some simple explanation using a diagram. The total length L bits is the message or data block M, variable length, and H means hash function, and the last one hash value h, the fixed length. So hash function uses. Hash function used in message integrity check, MIC. MIC always encrypted message optionally, and message authentication code, MAC, MAC. Send keyed hash of message, MAC, message optionally encrypted. Then digital signature, not repetition. Here encrypt cache with the private key and verifying with the public key. So hash functions are used this three most category: message integrity check, message authentication code, and digital signature. Here a simple key based cipher, a simple key based cipher. Above there are the alphabet letters from A to Z. For A 00, B 01, C 02 to 25. So agreed upon secret key is our key. Upon secret key is our key. The plain text. The plain text is A attack ATDAWN, attack at dawn. Here the corresponding A00 for T19, for T again 19, for A00, C02. This is the original plain text sent by the sender. Our secret key is our key. So our key, the total length of data attack at dawn must be replaced by our key. So O corresponding for 14, U corresponding for 20, and R corresponding for 17, and key K for 10, E for 4, and Y 24. So the total is in plain text and secret key. Some modulo 26 sum takes place. Cyber test is ONKKGIONUKAL. So the plain text is attack at dawn. We use the secret key as our key, and the encryption message is ONKKGIONUKAL. So the modulo 26 sum takes place during encryption, and the receiver side modulo 26 differentiate takes place. Whenever we differentiate, the recovered plain text is again attack at dawn is received to the receiver. This is a simple key based cipher. The next, decoding a key based cipher. Decoding a key based cipher. Here agreed upon the secret key is freshman. Once again, in the previous slide as we shown the alphabet letter 00 to 25. Here by LPEYBZ IRSTQ. This is the original. This is a cipher test by secret key freshman. So we can take the difference. The original plain text is what is your name. So here the what is your name will be decrypted as BELPEYBZIRSTQ. Then the replay is John Smith. Then key based cyber test with binary message. So in previous slide there is an alphabet for secret key, but here we use a binary code, zeros and ones, for secret key. Then public key cryptography. Encryption and decryptions are asymmetric. Knowledge of the public key does not allow one to decrypt a message. So here the Alice and Bob during transmission, the Alice is a sender and Bob is a receiver. Key making function, there is a big random number 52ED879E 70F71D92. So the Alice has two key, one is public key and another one is private key. So in the receiver side, the text message is hello Alice from Bob. Here encryption takes place, Alice public key, and here Alice send the message to Bob as hello Bob or hello Alice, decrypt using the Alice private key. Okay, here in the below you can saw that you can see the electronic signature, that is for authentication. So the authentication takes place using the private key and the public key for Alice, and this side private key and the public key for Bob's. So it is some analogy for public key cryptography.